it's a different situation, not really the same situation, but here the situation is the large language model is getting trained by the data that the user is giving. So it's a training problem, but then so it's anonym, like things like it's a trade secret and it got leaked, and the large language model got, which is a very specific situation, like you said, like a specific disease or specific situation, and somebody else asking a question in that specific situation got this answer because there's no other answer. Right?
Because original data collection is a very painful, effortful process, like I was saying, and it becomes its own research. So if you can find data that aligns with your research, it's really good. Maybe you're really lucky.
Good afternoon or good evening, everybody. So this is our fourth session, Research in the AI Era. And today's topic is going to be using AI for data collection and dataset creation. And again, today our host is Professor Roshan Ragil, and our guest panelist today is Dr. Isuru Nawinna. Coincidentally, both are scholars from University of New South Wales, Australia. And yes, so without further ado, I would transfer the podium to Professor Ragil to actually make the entry to today's topic. Over to you, sir.
Okay. Thank you, Kapila. And why do you think it's a coincidence? Right.
It's the same university.
No, I asked, why do you think it's a coincidence? Right. So let's start. And so today in the series of our the research in the AI era, so what we are discussing in the series is how the research is changing with AI. Not that I'm going to just use AI in research, but if we are talking about research, the different steps of a research method and how AI is changing it. And today's topic is on data. Like Kapila mentioned, we are talking about how we can, or what sort of data. In fact, like if you take a topic like AI, it's all about data, we'd say, right? So now we are going to specifically talk about in any research how we can collect and curate data, and also create, if required, data. In the AI age, we are also creating a lot of data. In fact, we have passed the point where the total amount of data out there in the internet has apparently passed, the AI generated data has passed the human generated data. So that's something to think about. And with that, I think I don't have anyone else other than Isuru to talk about it, who is the expert in the field and have been using data-related, data collection, curation-related work for a long time now, and have published in the area reasonably well. And also, I mean, whenever these days I go to any presentation talk, always I'm also encouraging, particularly those who are in Sri Lanka, to collect and use your own data. So I see Isuru as like a sort of a role model in doing so, and bringing him here is to also let him share his perspective on how Sri Lankan data can become part of research, part of the whole AI and other research, any other application research. So that's the whole idea of bringing him here. So to usually Kapila introduces the guest. It looks like he's letting me to do so.
Yeah, or else I had to say like my old friend.
Okay, so not so good. So given that Isuru is Kapila's old friend, we will let me introduce who is not his. So Isuru is actually one of my colleagues and also a former student. And I know Isuru for a very long time, and now he is a senior lecturer at the Department of Computer Engineering, and involved in a number of multidisciplinary research where he is working on a large amount of data. When it comes to data, so we sometimes think data is so simple. I mean, it's just data, right? So, but then if you seriously sit and think about it, in fact, like one of the people who made me to think a lot about data and how important it is Isuru. So it's the right time to talk more on it. So, like I said, Isru is, and like Kapil already introduced, Isru is from, completed his PhD from University of New South Wales, bachelor's from Peradeniya Engineering, and now a senior academic at the Department of Computer Engineering at Peradeniya. So with that said, let's usually, so when, like I said, now let's move on to the topic, which is about data collection and data creation, curation, I call it. And the idea is generally we spend a lot of time. In fact, like we have been doing data related research. I mean, any research you take, there is some data. Sometimes it's less, sometimes it's more. So that's the difference. So, but then when it comes to data, we have been using or doing a large amount of research. I would say, if I take myself, I have been doing the research for about 20 plus years, and all these years I have been using data. But and also all I have seen all my students using data. But generally, it is when it comes to data research, what the students used to think is okay. So I want to come up with the best algorithm to do a certain thing. Let's say I want to cure cancer. So what do we do? Okay, depends on the cancer. Let's say the cancer is breast. Then what do? We find a lot of data from somebody else's collection. Somebody collected the data of, let's say, some sort of imaging, and then we will come up with the best model, best algorithm, and then we'll compare it with somebody else's algorithm using someone else's data. That's what we have been doing for a long time, and by doing so, we are failing in a number of ways. One is the problems that we natively have. We are missing them because we are not capturing them properly because we are not using our data. You're using somebody else's data. So starting from there are a large number of different challenges when we don't take data seriously. So I just gave you one. So today's discussion is going to be on this topic. The topic is to one, why our data is important. I can think of, I mean, now that there is all these large language models, we can talk more about our data, right? So, like large language model, when you ask it questions, it gives you biased answer. So if you ask for a Sri Lankan somebody, it gives you somebody else. Why so is because we don't have our data. Our data represented, Sri Lankan culture people represented. So there are large number of such examples when there are problems to solve, when you have to represent ourselves, we don't have enough of our data. So it's time to discuss more on the data and how it works in the machine learning and AI era. And at the same time, we also will discuss with the help of AI, can we now do this data processing pipeline better, faster, efficiently, easily? Right. So those are also things that we'll be discussing today. So with that, let's jump on to the first question to Isuru. And hi, Isuru. I didn't let you say anything. So to start, let me ask the very first question from you. So, how important data collection and data curation, creation, all that in the case of form like framing, let's say a research project?
Um, Thank you, Professor Raghu. So I think the answer to that is it's quite important, perhaps as important as the algorithms or the models themselves, perhaps even more. So I think that the way I would like to look at this is, say in the good old days, we used to program systems to tell systems what to do in when you see certain scenarios, how you should behave, right? We instruct systems when we are building systems, but now that has shifted a lot towards letting the system learn from data. So just by that, data becomes quite a bit important. So a good analogy for this is say how a student learns. Like most of us here are in education, so maybe that's a good example. So um, so if you compare maybe complete verbose instruction by a teacher to a student versus self-directed learning, right? So completed instruction is somehow somewhat analogous to a programmer instructing a computer system, programming a computer system to about how it should behave in certain scenarios, whereas student self-directed learning is more like model training. So there, what material a student gets, what exercises, so what sort of content is included in the material, how the material covers the content, does it cover it properly, what's the quality of the material, the quality of the learning environment that the student gets, the quality of the teacher itself who sets the methods and monitors the students' learning and all that, assesses, all that becomes very important. So likewise, I think in model training, AI model training, data, not just how data is used and what sort of algorithms you are using, what sort of statistical methods you are using with this data, not just those, but data becomes super important, as that defines a lot of how good the model becomes at the end of the day.
Yeah. So that's the importance of data. But usually, like I told you, so the projects that we have been seeing for a long time, recently it's changing a little, but for a long time, the data aspect, this aspect is mostly undermined, or underestimated, right? So why do you think so? Why do you think the students underestimate this stage?
I think it's an interesting philosophical question, perhaps. Um, my intuitive feeling on this is what gets the spotlight these days is can you come up with a new algorithm? Can you come up with a new model that does something that previous models couldn't do, or previous models couldn't do as well? So that gets the spotlight, even in tech related media, or even in education. Whereas, what sort of data did you use for this? How did you look at it as a like a methodological step in your research? Doesn't get that same attention. So students, undergrads or even postgrads, when you think of a new research idea and start doing the exploration, you naturally look at these very interesting things, which are the statistical model. Can you change the model's parameters, or can you come up with a new pipeline using multiple different models? These sort of things get more attention naturally, rather than the data itself that defines what the model can learn at the end of the day. I think that's why, maybe one of the reasons.
So that also takes us to another question, right? So based on what you said, it looks like the general understanding that is that if you want to do a research, curating or coming up with the data is not going to be or is not considered a serious contribution, right? So a research contribution should be a model or a new model, something that does better performance or various other aspects of how machine, anything that method is given important, and the method is not coming up with data or curating data. So that is not part of the method. Is it true? Is it true? Like, can we consider coming up with the right set of data as a research contribution? That is what I'm asking.
Yeah, absolutely. So that's what we found out over the last so many years of researching on, doing research on these topics. So figuring out how you can use the existing data, or how you can improve it, or maybe going ahead and collecting your own data becomes even more important, I would say, in this day and age. Like they say, the data is the new oil. So it has a lot of value, and in specific areas, specific domains that are of interest to us academics, data is very scarce. So we don't have enough, if at all, in certain areas. So be it commercially or academically, but commercially viable domains get more attention, more funding to collect and curate data, like these LLMs came to be. So those areas we get a lot of data sets, and a lot of people are now working on, say, vision models and whatnot. And if they have a viable commercial application, naturally more funding gets directed to such research, and you end up having more and more data on these things. But certain other things of maybe more social value, like medical or educational domains, for example, don't usually get the same attention. So there's a lot of space to collect and curate more and more data, which will give the entire world more and more value. Not just, say, if I'm doing a particular research project, not just for that project only, the data you collect and make publicly available becomes valuable for a lot of other researchers to do more and more work that maybe you can't even think of right now. So and yeah, so like you were saying, it's very, very what do you call, advisable, recommended thing to look at collecting and curating data as a research question itself, even, because that is a huge contribution, that has a huge contribution to the academic world.
Yeah, just to rephrase it, like the whole idea of we doing a research is to solve a problem, right? So if we can present our problem as a data set, right? So if we can present our problem as a data set, then the problem gets solved. So a lot of people are going to look for solving problems, and they can find the problems in data sets, and then they can solve it. In fact, that is what I also realized over the years. What we have been doing is solving somebody else's problem by downloading the data sets and using them. I'm not saying like that is a bad thing to do, but then our problems are still here and not solved, right? So that's exactly how even the large language models are still unable to figure out who we are.
Yeah, and it's not necessarily a bad thing. Like you set out with some particular research question, and then in the process you find out that you don't have the data that is really needed to solve this problem, or maybe certain other related problems. So then that itself becomes research questions, like you said.
So, because we were also mentioning about problems. So generally, like when you, let's say you start with, a researcher start with some data and goes on trying to solve it. And at a later stage of the problem solving, let's say method, experiments, and so on, then they might also realize, it's a data problem. So we we missed it earlier, right? So they'll matter come back. So can you just highlight, because you have a lot of experience in working with data and this iterating this through this process, we'll take some examples a little later, but just to set the stage, when a researcher start with data and what are the situations later they'll realize, we missed it.
I think most of the problems that you might run into when you're developing an AI model for a particular purpose would have something to do with the data you started with, not really the model or the parameters. So say, just to set the stage, like you said, so say, I think one of the most important things here is if whether the data you used for the model actually matches what you wanted to do for your research question to begin with. So whether the demographic data that you use for a particular type of a statistical research really matches what you're setting out to do. For example, like you were saying earlier, maybe some medical diagnostic model was developed using by, say, European researchers using certain data, images, or other data collected in one or more hospitals. Then you go and apply this to you develop a model and then try to apply this to real world situations, general situations, and it doesn't really perform the same when it sees other data. So that sort of indicates the representativeness of the data that you used if your original research question was a more general application at the end of the day. So that's just to give you an example. So like that, I think multiple things can be traced back to the data. Anyway, whether your say model might be performing really good for certain types of inputs, but not for certain other types of inputs. Situations like that can be traced back to data. So these are more technical things, but then there are certain other more methodological issues, I would say, like perhaps when you're trying to you're developing a model based on the data that you collected, but when it comes the time to publish, maybe there are issues like, are you actually able to publish this data? Do you have consent by the data sources, wherever you source this data from? Do you have consent to publish this data? Or else maybe you do have consent, but maybe have you removed any personal identifiers, stuff like that. Say, can your model be used to trace something back to somebody's personal information at the end of the day who gave some data to be trained for this? It maybe not just their names included in the data, not very straightforward things like that, but say perhaps even without such very direct identifiers, if it is like say in the medical domain, a very rare medical condition recorded with some demographic collocation information in this particular area in a country, a few little things like that can be maybe used to trace back to that one person. Maybe in that area, there are only one or two cases ever reported. So just to give you an example, so such things can also become problems when handling data. So yeah, so most of the issues that you will run into in your research process can be traced back to data, be it some technical issues that the model when you're actually trying to let the model perform in the real world, these issues pop up and then can be traced back to data, or else it might be some methodological issue or regulatory issues that you run into at a later stage, which you didn't pay enough attention to at the beginning. So yeah, I would say most issues can be traced back to data.
Yeah.
I mean,
So
these are things that we learned
by
firsthand. Yeah,
by doing an
trial and error. Yes.
yeah, trial and error. So yeah, so in short, what you're saying is most of the problem that you encounter later could trace back to data, right? So if not all, in one way or the other, but at the same time, we also sometimes miss what has to be correctly done while using the data, right? So including properly anonymizing them to other various other aspects of like ethical clearance and whatnot, right? So it could be many one of those many. But I will a little later go into sort of a data, like a pipeline of how these things are done with your experience you can share. Maybe there you can also highlight how this could be properly done so that you don't end up um, in a difficult situation later in the research due to data. So when you talked about the example, the medical example, I also remembered something recently I read, I think last year, with the large language models. Apparently, like this one of these very rich companies, the corporates, see the what do you call the trade secret got leaked. And how it got leaked is by somebody querying and trying to prepare a report using a large language model, right? So it's a different situation, not really the same situation, but here the situation is the large language model is getting trained by the data that the user is giving. So it's a trading problem, but then yeah, so it's anonym, like things like yeah, it's a trade secret and it got leaked, and the large language model got, which is a very specific situation, like you said, like a specific disease or specific situation, and somebody else asking a question in that specific situation got this answer because there's no other answer, right? So and it's a trade secret, right? So as the audience might know, some of these things are kept secret, like for example, how Coca-Cola is made, for example, that's the most popular example given, the recipe for such things. So if data, yes, so it could also be possible. Rare situation can also lead to identifying who from where it's coming from. So now let's just take a step and move forward into how we go with good data. So what good data set means, how do you collect them, and so on. So so when you look at a data set for research purposes, what makes it good enough to support some good research work, right? So, or credible research work. I think you have done a number of, like I mentioned at the very beginning, number of research projects where you have clearly identified, started with the problem, and then identified the right research, right data, and then spend a lot of time curating it, and then use it to solve the problem, right? So you can talk about what makes it good data.
Um, yeah, so that's a good question. So I think the most important question when you're starting with a particular research project. So the main thing would be, now you would obviously go and see whether there's existing data, and because collecting and curating data is a very painful thing, it takes a lot of time and effort to do. Easier said than done. So you would obviously look at existing data sets, and people get gravitated towards these popular commonly used data sets because these data sets get cited in literature, in papers quite often. So it's a natural thing to try and use these data. So the first thing would be how does this data align with the construct of your research problem? Does it actually um, give you enough value to represent your what you're trying to represent here with the data? Say, maybe, for example, like a common example would be, say you're scraping data from the web to train a model about certain user preferences in certain types of activities. Let's say you might be scraping through maybe YouTube video clicks on YouTube videos. Can you correlate clicks with preferences? Maybe social media posts. You can scrape social media posts using web crawlers or bots to collect. Even you can now use AI to do this as well. But does it align well with your question? Does it align? So you are counting, you're taking clicks, that's the data, right? The number of clicks a particular type of post got. And then you're going to use that to represent maybe preferences, human preferences on a particular subject. Does it align really well? Right? There are enough data sets like that, if you very commonly found. And if your research is more sociological, we can easily use, or tend to use these things. Does it actually represent or correlate with the problem that you're trying to address with your research? That would be the first place to start it, to see whether the data set is good for use for that particular purpose. So whether the number of clicks that certain social media or maybe like YouTube videos or things like that get usually don't correlate with all types of questions that you can formulate. Like preferences. Preferences doesn't always equate to clicks because these social media content and algorithms are created and distributed in a way to attract clicks. So then that itself becomes a big bias in the data. So that would be the first place to start with, to check whether the data actually aligns well with what you really want to do. Then the next thing would be, now we would look at a data set and see, okay, this has this many samples, this has this many samples, this data set. So you take two data sets and say the first one has say 100,000 samples, the second one has 3,000 samples. So the first one is obviously better. More is better. But is it always the case? Generally saying, we have this notion in AI model training that more data is better. But does the data set present itself correctly with these numbers? Sometimes, say, taking another example from this, let's say, web scrape data, say some forum post like Reddit. Reddit is a popular place to discuss all kinds of topics. So you use a web crawler to collect or scrape data from Reddit on particular keywords, topics, and from a certain subreddit domain, and then curate this as a data set for, right? Then say a particular data set says there are 3,000 or 100,000 Reddit comments or Reddit posts for a particular opinion, expressing a particular opinion. But does it actually mean you have 100,000 samples if maybe quite a majority of these comments or Reddit posts come from a certain number of users? So is it n equal to the number of comments or the number of users at the end of the day? Does it becomes a different situation, right? So you can't really look at the number, but how that is represented, represented in the particular data set becomes also important. Say, for example, something that I ran into very recently when I was reviewing a paper for a Nature journal, a dataset paper. The paper was presented very nicely. It's about medical images, DICOM images, if you know. The medical images are often represented DICOM format, which are used by most scanner devices in the medical industry. And say this MRI, CT type images, you have a lot of slices in the same image. Say if I take a scan, CT scan of myself or a particular place of the body, you get a number of slices. And now this particular dataset, proposed dataset, was about identifying particular kind of a disease or diagnosable condition. So they have presented the data set as using the number as the number of slices, the total number of slices in the data set. But it doesn't represent the different the different cases, different patient cases in each of the classes that the data set is trying to represent. So in the literature for that particular paper, the numbers are cited as patient cases. That is the norm in the medical research, medical AI research. You usually present your data as the different number of cases in the different types of classes that your data set is representing. So when this particular article was presenting the number of slices to, show it larger than life, right? Make it look larger than real. So things like this can happen. Now, we as reviewers pick these things up, but sometimes it doesn't happen, and these things end up being published in official repositories. When you see such data sets, have to think about these things as well to see whether it has enough data, really enough data, not just a lot of data. It might be a lot of duplicated things. So how many data points are actually available in the dataset is something that you'll have to look at. And then the quality of the data itself. Like I said, if you're trying to build a medical diagnostic model to be used in, say, Sri Lanka, because that's our context, so you will find a lot of European data available because they collect and publish. They have collected and published a lot of data. So can you use the same data set to and with certain modifications or whatever to infer the same diagnosis in the Sri Lankan context? That also becomes a thing that you should ask, whether this data set is good enough to be used for your research. Sometimes, say if the data, let's say skin cancer, if the data in the data set is dominant with light-skinned individuals, if you use it for a more darker skin situation when you're inferencing, build a model and inferencing, you will most likely run into issues. So the quality of the data, whether the quality of the annotation, the labeling also becomes important. What types of annotations and ground truth labels are available in the data set becomes very important whether it's usable for your particular research or not. You might have to supplement. You maybe take the same data set and add more value to that, add more ground truth value to that at the end of the day. These things are possible, but that is more work for your research team. So so these are the things that sort of we learned along the way. Um, so when you're looking at published data and when you're publishing your own data, if the data set includes some sample tests using benchmark models that using this particular data according to a split like this standard benchmark model performs like this. If such benchmark data are included along with the dataset, that's useful for you to identify whether or not you should be looking at this dataset and how well can you use this dataset for your particular research. So such standardized information is also important. Yeah, these are the things that we usually look at.
So yeah, so generally, like you have highlighted about, uh, in fact, like just a general thing, like in research, right? So the quality versus quantity discussion, it looks like still the researchers, even data researchers, are thinking that okay, so we can add more numbers without worrying about the quality, could add some credibility to them, right? So that may be the reason why they're doing so. But then obviously it's a more of a quality versus quantity discussion, and the quality, the more the better than the quantity. And also obviously something related to the quality, you also highlighted the relevance. So whether it's relevant to the problem that I'm solving, maybe I have. So when it comes to relevance, it's we have to look at other aspects, like not if you take a disease, for example, because you are more working on medical data. So a disease, it's not the same everywhere. Like even if it's the same, it depends on the color of our skin or a tone and other aspects, and our habits and our physiology. It could be different, right? Even for the same problem, same sickness, same disease, it might be different type of data, and something that is of somebody else's might not apply to us, and we might not be able to do our proper diagnosis and whatnot with their data on us. So right, so that's like the relevance that you highlighted. So in addition, you also highlighted that things like when you are collecting data, it's not just about the quality of the data, but how good you curate and label it, right? So whether we can find the right information identified within the data and also marked by experts and their opinion. So this is a place where again the experts are coming into the picture. Depends on the domain, and the people have to know which is the most important aspect of the whole data set that we have, right? So and also to properly label it and annotate it so that whatever the research is, even if it's a machine learning model, the model can find that particular aspect of the data, not all the noise. So it's basically the noise to data ratio, right? So the easier the
Yeah, I think that
so
that's one of the most important places. Say now you're trying to capture certain intelligence that is like tacit intelligence that humans have, um, human experts have, and then transfer this to a model. So capturing that, what are the parameters that you want to use to capture this becomes an important thing. You have to really seriously sit down and think about what sort of annotations, if it is on images, what are the things that you need to visually annotate, what are the non-visual metadata that you would need to identify this particular medical condition. Stuff like that become very important. At the very beginning, you need to really think about and decide on these things.
So now if like, yeah, so let's just take a step further. So now we are talking about, okay, these are the good qualities. These are the things that you have to look for in finding data, or good data, we call it. Right. So when you understand that, the next question is for researchers is to how we really obtain or actually collect or find this data. Right. So let me ask a question in that line. So we'll explore actually a few different options. You already have mentioned them, but we'll go into more detail on data collection. So how should students, if they are choosing data, how would they, or finding data, how would they choose between collecting new data or reusing existing data or combining both? What are the, so you already mentioned a few like situation, but I'm asking specific so that it can be clearly differentiated.
Yeah. So so going along the direction that we discussed so far, so the first thing is to decide whether the available data are good enough. Are they actually aligning with your research question? um, if the answer to that question is yes, then that's good. It's a lot easy to reuse existing data. One of the reasons that you should contribute data through your research, um, because original data collection is a very painful, effortful process, like I was saying, um, and it becomes its own research. So if you can find data that aligns with your research, it's really good. Maybe you're really lucky. Um, if not, then the next thing would be, can can you find data which has some value for you, but there are some coverage gaps. Maybe the population that the data was collected from is not exactly what you want, or maybe it's from a different time frame, not really relevant to the current day and age. So these things can be there as issues, but the data still can be useful to you for a certain extent. So um, can you then take this data, take the available data, and augment that with maybe synthetically generated data, or even manually collected and new, maybe a subset of new data that you can collect, not completely collecting a full data set, a small number of samples that you can use to fine tune a model. So that's the next thing that you should look at before deciding that you really have to go ahead and collect new data. Um, but that might be, you eventually might end up at that conclusion that this particular research question might need new data to be collected and curated. Might not be able to avoid it all the time, but that's not necessarily a bad thing. So that reveals a research gap in the literature, not exactly the problem that you started with, but another problem that underlies that. So that becomes a problem that you can solve.
So generally, when okay, so that like I was also telling you that we used to use public data, right? So a lot, but now we are talking about the challenges. But can you, what are the situation? What are the other situations where it is advantageous to use public data, other than the obvious reason, like okay, it's easy for us, we don't have to collect. But are there any other advantages in using public data or data sets?
Um, it uh, when you're using publicly available data, well, yeah, the obvious thing is it's easy, it saves you a lot of time. Um, but it allows you to push something that somebody has done a little bit further. And so it's you know what research is, right? It's pushing this boundary of knowledge that humans have created a little bit further on a particular place, right? Particular area of your expertise, you push it a little bit further to create more knowledge. So here's an area that somebody had worked on and pushed a little further. You have a lot of data that is available, but can you use that same data to create even better knowledge, even more knowledge? So that gives a good opportunity for that. Mm, what else?
So yeah, so I was also thinking in the same line, but from the other side of it, right? So because if you want to now validate some great idea that we come up with, right? So okay, so now I have this superb AI model that can do this and that, and if I want to ground my idea, how to compare and validate. You mentioned about benchmarking earlier. So even that you are saying the same thing, but I'm putting it in a different way, right? So I come up with something new. So if I want to compare, okay, if I have my own data set and if I do this, I don't really know how good it is. Uh, how good, okay, so I will know whether I'm solving my problem to some extent, but I will not know whether I'm doing something brilliant, like compared to somebody else who had done it, unless I take their method and try it on my data, right? So this data becomes sort of a common ground where we can try different solutions. That's what you're actually explaining, but yeah,
Yeah,
I'm
yeah.
showing it from the other side, talking it from the other side, right? So it becomes a common ground. So for it to be a common ground, we had to have the common data. So even if you are not using what you are trying to say there is, I think is even if you are not using public data, we'll have to, if our data is going to be the standard, the common ground, then we'll have to make it public so that it becomes a common ground, so everybody can try out their solutions and see whether uh, they are the better one, right? So their solution is the better solution, so that it goes beyond. I hope
Yeah,
that's okay.
it becomes very useful for comparison purposes. Like I said, say even these medical data sets collected from particular demographics, like say Caucasian skin colors, might not apply the same way to other ethnicities, the demographics, but it becomes a useful thing to compare with at the end of the day. So you might even collect your own data or augment that data set, but to validly compare and say whether the model and parameters that you have been you developed here, how good they are. You can do a good comparison with the already existing public popularly used data set. Becomes valuable to get for researchers to get a good idea.
That also brings us the competitiveness, which is good or bad, but it's something that is useful to go beyond what we are, right? So like you said earlier, that's good. So let's now take it to the next level. So we were talking about data, how it is useful, how it can be curated, sort of whether it's public, whether it is our own data, and so on. But let us, now that we are also talking about AI in the research in the age of AI. So in the sense, like for instance, now if data collection curation is a research problem, how can AI be used to make it better? Right? So because that is the core of this discussion as well. So the research problem is, let's say, curating data or finding data, like coming up with data, proper data set. How can we use AI? I think you have used AI to do some data things or coming up with data. So how do you take?
Yeah. Um, I think that's a very sort of timely question and very relevant to this particular discussion. Um, the first thing that comes to my mind would be the scale of possibilities, scale of operations that are possible with and without AI, scale and speed, I would say. So, um, I'm trying to think of a good example here.
You can share. I mean, we didn't get a time to share your work, like a specific examples. Maybe we can take one of them where you can say how you use some AI ideas to, or AI to do the curation better, faster, or scaling, like you said.
Yeah. Okay. So, what by scaling, what I mean is now, say you are trying to collect. I'm going with medical examples for the most part because we have been working with biomedical problems a lot. Um, so now we are trying to um, come up with a model to diagnose particular conditions, let's say. And here you are collecting data. Now you are required to collect data either to augment existing data sets or to curate a new data set. So um, maybe hospital records, maybe something that people would usually go for such situations. And it's it's kind of an excruciating thing to collect physically collect these hospital records for falling under a particular criteria, but to be relevant for diagnosing a particular condition. Patient cases that have been recorded in a hospital already, or maybe you're recording them as part of your project. So in the hospital records, extracting the important information that you would need to feed into your model at the end of the day is that is not an easy thing to really do. Even if you get the data, even if you physically collect the data either electronically or even manually on paper, if you collect the data, it's not an easy thing to filter out the important things from these text, because these are not very straightforward and not what you call not normal, because it has a lot of jargon related to the medical profession, a lot of acronyms, for example, a whole bunch of acronyms written in short form, but not very easy for a person to look at all these stuff and extract the relevant bits out of this. What were the tests done for, what were the test results, stuff like that. These are written, like manually written, entered. So that takes a lot of time for maybe a research assistant or researcher to go through the collected data and extract the relevant parts of it. So, but if you use the current AI technologies that are available, you can do this a lot faster. You might have to use specifically developed AI tools for this, where the models are trained on medical acronym, medical jargon to understand hospital records easily. Such things are now coming out in the research in academia. So it makes things a lot easy to quickly filter out data from either the web or collected medical records or whatever it is the original source is, to extract the relevant data using AI. So that gives you possibility to create a bigger data set with a shorter time span, in a shorter time span. So I think that's one of the biggest advantages that the current day and age AI offers in collecting data. In addition to that, even things like annotating, adding the ground truth labels into the data set, AI tools can help a lot. This is a bit of a chicken and egg problem now. Say, you're trying to develop a model to diagnose certain things looking at the data, right? Okay, you look at some images and medical images and trying to diagnose whether a particular markers for a particular condition is there or not. But then you're now talking about, can you use an AI to do the marking of the markers as well? So
I wonder, this is the bias problem you mentioned earlier.
yeah, but it still ends up becoming AI become very useful in that particular operation as well, because I think in maybe different ways now. If say a group of medical experts sit down and go through a whole bunch of medical data to add this ground truth knowledge, right? say we have say 5 specialists in the research team who are going to look at the medical data, the say CT scan images or whatever the relevant medical data, and then add the ground truth label. Does this have the condition or not? Is there a particular feature in the image that you need to mark or annotate visually, things like that. So these experts have to sit down and do. It takes a long time to do this. Lot of time and effort is needed to do this, but what you can now easily do is get some AI models to do maybe one pass of this, um, uh, to do the initial annotation, initial ground truth labeling, and then the experts have to go through this and review and then make the changes. That is a lot easier realistically than doing the entire thing manually. Creating the annotations and ground truth manually. Compared to that, this checking and updating is a lot easier, right? That's a natural thing, right? Rather than writing your own answer to a question, it's easier to look at somebody else's answer and then understand it and then maybe even improve it. That's a natural thing, right? So yeah, so that still has a lot of value, even though your model can't do a perfect job in annotating the data. That's understandable, but it still gives you a lot of value in saving this time and effort. Plus, I think another sort of not very visible thing is the consistency in the ground truth data that you're adding to your data set. Now, like I was saying earlier, if there are, say, a team of, say, 5 experts sitting down and adding the annotations to the data set, say you are one expert, I'm one expert, let's say, for example, the way that you would do these annotations and way that I would do, even if guided by a specification, there are slight differences. So the annotator bias can be a thing that affects your model's performance at the end of the day. So a useful thing when using computerized tools to do this, AI tools to do this, at least as an initial pass, is you can avoid some of these little changes, the inter-annotator differences that might creep into the dataset, because at the initial pass, the AI gets it into a level range, and then the experts fine tune it and place it at the correct level if there are any differences, discrepancies that come into the data. So that's something that is not very visible or easy to spot at a high level, but if you're using tools to do this, that is an advantage that you might be getting. Something to add here is that there are techniques called few shot learning techniques, where instead of now we sort of understand that if you have more quality data, then your model will do better. That's a general understanding with certain caveats, but can you make a model learn with a small amount of data? Usually it's a difficult thing to do, but for certain things it can still use techniques. It's something like say if you show if you take a very a tiny toddler who just started to talk and show that little kid maybe 2-3 pictures of zebras. That kid might never have seen a zebra for real, but you show them maybe 1 picture, 2 pictures of zebras, they would know what a zebra is, right? When they see another different type of maybe like a toy version of a zebra, they would know that this is a zebra. So like that, it's possible to make a model learn certain facts without having a whole bunch of data. So this few shot learning techniques can be used to make models or develop or fine tune models to um, help you with annotation labeling of larger data sets, which then experts can take and adjust, fine tune the ground truth labels further. Without that step, I think it's a bit of a risk that you're taking without the human intervention. But still, the AI helps to get this done much faster with less discrepancy between different humans involved in the process, stuff like that.
Yeah, true. Like, I mean, anyway, so the what you said about human in the loop, we are always when it comes to AI making decisions, even annotating or scaling, doing anything with data, again, we have to have human involved in one way or the other, right? So that's very true. So you were just to summarize, so you have been talking about so how basically what you have been talking about is how basically we can use AI to do the like data collection, annotation, that sort of like if you're going to curate data sets, how do we use AI? So in general, we can use it for scaling, but at the same time, we can so scaling meaning like to do more things faster. And therefore, what are the things that we can do faster? Are extracting data, filtering them, annotating, labeling, and to make sure some sort of consistency is maintained across multiple annotators and so on. So there are ways of doing those, but at the same time, we also have to make sure the human or the experts are going to check and finally approve so that the data that we are going to collect and curate are going to be human collected, or it's AI is only going to support or just make things easier, but we still will be using human as the last check. So that's so we are talking about a boundary here, right? So we're talking about data and then the AI coming in and helping curating data. So when in situations like this, what are the risks? What are the risks and weaknesses in this process? You see, like we already see that, okay, so if you're going to use AI to do this, there are a number of challenges, like it can go wrong as well, but human can come in and help. So what are the main risks when AI is used too heavily or too casually to dataset creation? Do you have anything else to add other than like what we discussed earlier? You
Um,
highlighted.
yeah, so one thing actually I missed to add was the generation of data, like which is a big thing.
Okay,
Um,
synthetic data, you mean? Yeah.
Synthetic data, yeah. I think we touched upon this a little earlier in the conversation. So, synthetic data generation is also becoming a big thing where data is it's not easy to collect real data. So, for example, there's something that we've been trying to do recently to say diagnose certain heart conditions. Can you come up with a data set of cardiac MRI images which contains markers to diagnose this particular condition? Realistically, practically, to do this, it's very difficult because um, a medical team of specialists would only at a very late stage in the diagnosis they would use this technology like cardiac MRI scanning just to confirm. When they need to confirm their diagnosis, they would do this. Even forget about labeling the data, but even just that data to be available in some obscure place somewhere in the world, it's a very rare thing. You'll be hard pressed to find even a handful of such images. So in situations like that, can you generate synthetic data to represent this condition accurately? So this is a very sort of new place that AI data generation is becoming more and more useful and more good at. So we've been also trying to do certain things like that. Um, so yeah, so that is something that's interesting, and gaining a lot of attention.
Yeah.
So
But anyway, in general, that is also true, right? So, but I understand specifically in situations like medical imaging, the what we are trying to do with medical imaging, in my understanding, is that we are trying to find some anomalies, something that is not normal, right? So when it is something that is not normal, it might also mean that it's rare, right? So it's not always happening, and therefore finding such data might not be a common case, right? So like you took an example from a specific situation, but even I remember doing a research very recently, about a couple of years ago, on some bone related, like bone broken bone, like some accidents related bone. So whether something is broken, a particular bone is broken or not, we have to figure this out using X-rays. So if you want to go and collect data for bone related such an issue, if you go to that particular unit or hospital and start collecting, all what we see are broken bones. Uh, we don't, because it's the opposite of what I said, but like it's still true, because we don't just go and for fun take X-rays of a bone to see whether it's all okay, right? So you only go and see whether it's. I mean, and also specifically in countries like ours, resource constrained, that will be the last resort to go to.
lasting, yeah.
Yeah, that is what you're also saying, right? So the last resort to go to. So then, yes, the one problem is there'll be less amount of data in that particular problem, because we don't do it more often because it's expensive. MRI particular type of things are very expensive. So we don't really do it until like the last moment. That's one. The other side is we will not do otherwise. So, which also means we don't have like, so just for everybody's understanding, so for a machine learning model to identify such problems, we also had to give it enough data to do some experimentation.
So, I don't hear Roshansa anymore. Is it the same experience for you, Isru?
Yes, seems
Okay.
like his connection is
Well,
frozen.
yeah,
Give the
let's.
opposite,
Sir, excuse me. We didn't hear you for like 15
yeah,
seconds.
yeah, I heard that. I heard the part that
We were
which
bad mouthing it.
so yeah, what I was saying is, so it's on both sides, right? So one side it's we don't have like enough data for the anomaly, and also at the same time, because we are a resource constrained situation, even otherwise we will not take data which is the balance side, the other side of it, so that we have enough balanced data to do something useful, right? So that I just thought about. Yeah, I sorry, I interrupted you. Yes, go ahead. Yeah.
You know, it's an interesting thing, and that factors into your research design decision at the end of the day. Say, even without looking at the synthetic data generation, say 99% of the data that's available are normal, whereas the abnormal condition is 1%. If you use such a data set to train a model, what would happen is the model would very likely learn the pattern that most of the data are always good or normal. So it would just to satisfy its learning criteria, it would just pick up saying that given data is normal,
Yeah.
which is of no use to anyone. So, yeah, so when you let a model learn patterns, giving a balanced data set with the classes balanced properly is quite important at the end of the day, and AI comes into this picture. Yeah, okay, if it's really hard for you to find data from a certain class of abnormality that you're trying to detect or a preference that you're trying to detect, um, can you generate data to support that? So, but then at the end of the day, your generated data needs to be accurate and validated by human. So, human in the loop is an important thing at the end of the day. Um, but going back to the question that you were asking, you're trying to go into these risks of using AI.
Yeah.
Say the one of the easiest thing is it's easy, right? Say it's easy for you to use AI, so you just tend to use it without precautions. Say if say there are tools like label box, which is a like a common popular tool that is used to annotate ground truth data in data sets. It has such AI features built in. The current versions, the paid pro versions have such features built in, so you can put a bunch of images and get the tool to do the annotation. It does a fairly decent job. You look at this and then go ahead. Okay, I have now a good collection of data. Moves on to model training. Um, so there's a risk that because AI outputs look quite good these days, you just take it for granted. That's the first risk I would say. That happens in even the common use of ChatGPT, like LLM-based chatbots, right? It talks to you like a human. It talks, interacts, converse with you like a human would do. So you would take for granted whatever it says, assuming that this is coming with some sort of, realistic cognition behind it. So the same thing can happen with research data curation as well. You use a tool to generate data, or even extract data from messy source of raw data, extract certain terms, that certain keywords or terms or values, numbers that are relevant to your research. You use a tool to extract it. It does a decent job, but you move on without validating that. So human in the loop is an important thing. That's what I'm trying to point out. That's the first risk that we run into. Then the other things are, say, now, now we mentioned at some point that, say, if a collection of experts are adding these ground truth values, the expert knowledge into the data set, human experts, there may be certain variances between the way the different experts are doing the ground truth labeling process. What one expert would do does not exactly matches with another expert based on their particular experience and their patterns and the way they understand and execute things. So AI solves that, we said, because it's a more computerized systematic tool, so it reduces these variances. But then if you keep the human out of the loop, the issue is, if the AI is also not perfect to do this ground truth labeling, and the way it adds an error is a more systematic way, right? So that error becomes a systematic error in the data set. It's not a random error. If the error is if the error is coming from different humans, human experts, it becomes random. It becomes noise, and it becomes maybe less relevant if the errors are all kinds of different errors, random errors. But if the AI is adding the error, it's a systematic error. So then that most likely goes and biases the model towards that error, because the data is now biased with a certain error for the most part. So human in the loop is really important. Even if you generate synthetic data, good data, human in the loop to validate this and adjust, correct this ground truth label becomes super important. So that's another risk. And the other thing I would say is something that the entire industry is experiencing now. You use generated, you start with available data to train models, and then the models generate data, and then you use generated data maybe even with human validation to train more models, right? So recursively, more and more data will be available out there, which are machine generated. Then that that sort of drives you away from the real situation that you were trying to represent with the data in the first place. So this happens over time, not just in one iteration of research, but over time. So I think these LLM models started experiencing this maybe a year or two back, because a lot of data that are out there on the internet now are machine generated. Whereas when the big companies started training LLMs using available data on the internet, most of the data are human generated. Still, there were a lot of noise and garbage that were out there. They need to filter all that out. But now it's the opposite. Most of the data are machine generated in the internet. So now they are facing problems using the available data to fine tune or improve the model, but the model drives away from the real situation now. So that's a risk that people will tend to face increasingly as we go. Um, so yeah, so something to think about when using machine generated data. But for now, at least, the thing that is to be emphasized is human has to be in the loop. So the real experts have to look at this, just use the tools as a productivity enhancing method to get things done faster, get more things done faster, um, but still use the human experts' time productively to make sure the quality of the data is still there before you proceed.
Yeah, so something maybe we had also highlight at this point is that when you're generating data, if the data is about human behavior, for example, right, or of that nature, uh, particularly in social sciences or sociology type research, synthetic data is going to be, I mean, it is more of an LLM problem that we already have passed it, and if you take data from generated, it's going to be AI generated data, and it's not going to be human behavior anymore, right? So that's just one specific example. But in general, what you're saying is, yeah, so these errors that the AI generates, the data has are more systematic errors, and therefore they are going to be problems. Like there are going to be situations where we will not be able to cancel them out, like as random errors usually are. So I was just curious, right? So you were talking about this app, you mentioned some name of an app, and they do like labeling and whatnot, but obviously they are not so good. That is why we are doing this research, right? So if they are good, then we don't really have to do build more models, right? So yeah, okay. So that's basically like the last part of the discussion I wanted to discuss on. And you said you have something to show us. Do you have some tools, examples to show, Isru?
Um, yeah, so yeah, we have some stuff prepared. So let me. Are we on time or are
Yeah,
we a little
okay.
bit behind?
That's okay. We have some more time. We are into sort of almost the question time, but because yeah, we are talking a lot about data.
Yeah.
Uh, but,
Okay.
we can take a few,
So
show something that the pipelines or whatever you build. So it will be useful, I believe.
yeah, um, maybe we'll go for a little demo. This is try to share my screen. So I hope my screen is visible.
Yeah, it
Yeah,
is.
screen is visible. Nice.
And we see
All
a
right.
paper.
Yeah, so this is something that we published a few years ago. One of maybe the one of the early places where we really got serious about data collection and building data sets. This one was for detecting um, uh, oral cancer at an early stage before the cancer gets serious. If you can detect it, then there's a lot that you can do. So, can you do it using just a photo taken by a mobile phone, right, without fancy scanners and lighting and whatnot, right? Just can you take a photo of the mouth and know whether there's something to worry about or not that can lead to cancer. So that is where this the sort of like the premise of this research, and it led we sort of went through all these data problems and ended up creating our own data set. So we went through all this data collection, ethical clearance, data, pre-processing, cleaning, removing all the redundancies or duplicate data. All these things we learn firsthand by making mistakes. So this is now publicly available. The dataset is available on a Zenodo. Zenodo is a popular repository to host medical data. Let me see if I have it open here. I don't think I have it open here. So yeah, Zenodo, Zenodo, Zenodo. It's a repository hosted by CERN in Europe. So it has a lot of good data sets. So our data set also ended up in that repository. So just to show you, maybe I should ask, like, is it okay to show graphic?
Yeah.
Yeah.
Hope we all are by consent here, so it's okay. Okay.
So the idea here was, say, if you look at these images, it's very difficult for a normal eye to know whether a particular, say, a lesion, a marker that you can see inside the oral cavity is malignant or not. You and I, if you are not an expert, would not be able to do that. But a medical expert who is, specialist in this particular diagnosis can look at this and get a good idea whether, how much of a chance you have that this thing is going to be malignant, and they can then proceed that into testing and verification, like confirming whether the case is real or not. So the idea was to collect this data from Sri Lankan population and come up with a model to quite accurately detect this at an early stage, and then eventually come up with a software tool, AI-based software tool that the doctors can use throughout the country to detect cases early, so these things can be prevented from progressing into serious situations. So say these were some of the samples of the data that we collected. So we had to collect data from healthy samples, benign samples. That means markers are there, but they are not malignant. The lesions are not malignant. And OPMD are the markers are there, pre-malignant markers are there, and they're actually leading to cancer. So it's very difficult to distinguish between such things visually. Then the other ones, the last class here is actual developed cancer. So so the data set was collected like that, and the data had to be labeled into these classes, and then the annotations also included things like these boundaries, like, say, if you just present the entire image that's taken from a smartphone into the model, it would look at all the pixels in here, including everything outside the oral cavity as well. So that would affect the different patterns that the model would try to learn from this image. So you usually want to remove unnecessary things that the model should look at so they don't take such things into account for its learning. So say this marking the oral cavity, so the model can know that okay, I only have to look at inside this, not outside this. That's one of the things that went into the annotation. And then these lesions, the lesions are there, the marking the boundary of the lesion, so then the model can try to identify. So certain types of lesions are markable or visually identifiable like this. Certain types, other types are not easily visually identifiable as well. So things like that go into the annotation. Now this led us to the situation where how can you do this easily? Like you have thousands and thousands of images that you're now collecting at a hospital where patients are coming in, and now you have to do the labeling and annotation. You need a convenient way to do this. Forget about AI to getting AI to do this, but you have images, you have to annotate. Doctors have to annotate this manually. So then we went and build our own tools to do the annotation, which proved really useful. And then we used the same tools to annotate this data set, the tools that we built to curate other data sets as well later on. So we have a little demo of that prepared to show you how how these tools are used. So I invited one of our former students, Chandula, to help with the demonstration. Chandula?
Yes, okay. Let me share my screen. Right.
Yeah, working.
Hope you can see my screen, right?
We could. Nice.
Yeah, okay. So this is the Oasis annotation tool, which is hosted on our university servers. So actually, this is a online tool, right? So we need to have a user registration and a login. So basically, we use Google login. So from here, any user can submit a register request with their Google account, and then once admin accept, the user can log into the system. So let me log into the system. Okay. So after the login, the user is redirected to this page, which displays the unedited images by default. So in a system, actually, we maintain two roles, the annotator and the reviewer. So the system is designed so that the annotator first complete the annotations and the labeling, and then need to request a review. Then the reviewer needs to go through all the annotations and labels and check whether those are correct. And if there are no issues, the reviewer will approve it. Or if there are some minor issues, the reviewer can correct them. Or if there are more major issues, the reviewer can request a change and can ask to re-annotate it, right? So, however, with this, each image will go through at least two domain expert before the finalize. With that, we hope this will improve the trustworthiness and the quality of the data set, right? So right now here we can see three tabs, right? So the first one is entirely for the annotators. So under that we can have different views. So example, here we have the unannotated view. So here we here we see all the non-edited images, right? So by clicking here, users can switch views. Let's take edited view. So here we can see the edits done by the annotators, but haven't request for review. Basically, halfly done annotations. So, and let's say change requested view. So here we can see the changes requested by the reviewers, right? So, and we have another two tabs. So if we go to the request tab, this tab allows reviewers to see all images submitted for review, right? So this is basically for the reviewers. And then finally in this section, I mean the approved section, we can see all the finalized annotation approved by the reviewers, right? So yes. So let's choose an image and go through the entire pipeline, how we do the annotation. So right. Okay. Here I want to raise one point. So as Dr. Isuru said, we need to think about whether we exposing personal information of the patients when we present, share in our data sets. So even in the annotation process, also here we use fully anonymized images, right? So if I talk about the annotations, so here we can perform two types of annotations actually. Drawing polygons and or placing dots like here. So also we can categorize what we are annotating. So currently this tool is customized for root canal treatment dataset. So that's why we see these kind of categories, but we can easily add more categories here. So either we can select existing ones or introduce new ones. So by this we can customize our tool, right? And okay, then let me go back to my image. Right. So now as a demo, I'll do a couple of annotations. So first I'll choose polygon type annotation. And as I here, I'll annotate treated tooth first. So we can just put some dots here. And the software will connect those dot one by one. And eventually we will have the connected polygon or the annotated tooth region. So to finish the annotation, we need to click on the starting node, right? So we'll do another one. This time let's do a root filling. So like this, we can do the annotations very easily. Okay, let me do it very quickly. Again, you need to click on the starting node. And after drawing the nodes, actually, we can still edit these points locations and fine tune the our annotations, right? Like this. And in addition to that, actually, we can mark some positions, right? So let me choose root apex point. So usually we dot type, we annotate the root apex point here. So I'll put it here. Okay, right. So also we can delete the annotation if we done something wrong, like let's say we annotate something like here. So easily we can select on that annotation and like okay, we can delete those things, right? And not only that, we can assign labels also. Like here, we can select the status of the filling length, whether it is correct underfilled or overfilled, or let's say correct, and whether the filling has a good lateral seal, and voids, is there any voids or irregularities present. So for the moment, I will select absent. So that's how the annotator do the work. So now the annotator's work is done. So now the annotator can save their work, and then they can request for review, right? Okay. Then now we can close the window, and then here in this request tab, now we can find the latest annotation. Actually, the review request, right? So Also, the reviewer can do the have the every facility that you have given to the annotator. So even the reviewer can select these annotations and correct those points, right? So after correcting those things, reviewer also need to save their work, and then finally the reviewer can approve the annotation, right? Okay. Then now we can close the window. Then here in the approved section, now we can see it, right? So let's say the finalized annotation also have a little issue, then also the image can reopen, and then it will go to the edited tab again, edited view again, right? So finally, after the approval we get, after the approval from here, we can download the annotation for each image, right? So like here. So for right now, for this we can get a JSON file image. So if we need to get the whole data set, then the user can log into the database and download the whole annotation set as a JSON or CSV file. So actually here we implemented a very simple workflow, so even non-technical person can log here and easily learn and adapt to the system, right? So that's it.
That's an interesting tool. So this is something that you build over time, right? So for the specific work, so it's possible for us to build similar tools as and when we need, so that we can use them, right?
Yes.
How hard is it to build a tool like this? That's something useful.
Actually, this is originally built for that oral cancer project. Then we got this tool, and then we customize this to annotate datasets. So uh, uh, this root filling kind of datasets.
Um, yeah, it's not that easy to do, but it's not too difficult to do as well. Like once you understand from a research methodology perspective what you need the tool for to help you with curating the data, you need to be able to add the data to the system and then manipulate to add the expert information to the data, the ground truth labels, annotations, and whatnot. And in the process, you need all these facilities like you need to say make sure that one particular data point is reviewed by multiple people to make sure that you are removing int annotator biases and whatnot. So the features need to support all this. So this it becomes a bit of a software development project. Plus, at the end of the day, you need to be able to get the data out of this system in a way, in a format convenient to be used for machine learning model training. You can't just give, say, images with drawings on it, because that then adds more complication for the next steps in the model training process. So you would need to give these in standard digitalized data formats like this COCO format using based on JSON objects and things like that. So then researchers can quickly export the data set and then use it straight away into the model training pipeline. So those are some things that we thought about. The next things for us to do with this particular tool is to make it maybe open source, so people can set it up and use for their own projects. Then adding these other AI based features to improve the productivity in like initial annotations, whatnot. So that is another like a research problem that we are trying to solve. We were trying to come up with different few shot techniques to look at a given data set and come up with the annotations very quickly. Like the researcher can give maybe a few samples, like maybe 10 samples of what the annotation should look like, and then the model does a pass over this entire data set, and then the researchers can then cross-check and validate. So the features like that, hoping to bring into the system. These are not, very new things. These are already out there in commercially available tools. The problem is that commercially part you have to pay to use such features. Like there are tools like Label Box that we have also used to label data. They also have these facilities plus these AI generation, synthetic data generation included into the loop. So, but you had to pay, you had to be subscribers to use this. It's not overly expensive, but still you had to pay, and can be a problem for countries like us. So that's why we are trying to put these tools, make and put these tools out there, so the community can benefit from it.
Kapila, are you there? We have questions. Maybe time to answer them.
I'm here. I'm here, and I think Kasum has posted a list of 5 questions.
Yeah.
Actually,
I
maybe I'll go with Kasum's question first, and there are some other questions that
Generally, Kapila, I saw Kasum's questions. Some of those questions are about data analysis, which we'll do later.
and
But
some I think already answered by Isro.
yeah.
So anyways, let's go through these questions and maybe we can quickly comment. And then I have this set of other questions which might require an extended answer. Kasum's questions. What are the specific and accurate AI tools for data analysis? So maybe, sir, it will be not the next session, but the session after,
Yeah. So
right?
we
Next
haven't gone into any data analysis, so it's difficult to answer them directly now.
Yeah.
So we will pick them up later. Yes. Yeah, one after next. Yes.
one after next. Yeah, next month, I think the second week or so. So I think he's in the context of data analysis, he's asking this question, but maybe we can, zoom out and ask the same question about the annotating tools as well. How about the accuracy of those tools? Isar, if you take this as a general question.
It depends on the type of the nature of the data that you're trying to generate, or annotations that you're trying to generate, but they are reaching really good levels, especially like if the data is more text based. They are becoming really good, the generated data. Then even like there's some stuff that we've been trying to do recently, the spoken natural speech data, generating speech data, which we have not had great success with that. We wanted to generate certain data, speech data, single spoken data. So that we didn't have good success. So we are trying to come up with our own solutions to generate such data. These things can be traced back to the lack of data to make the models to generate the data in the first place. So so the answer is it depends. In certain domains like English text generation, it's really pretty good, sometimes scarily good, the types of data that you can generate. Whereas like maybe audio generation, even like things like music generation, we have been experimenting with. It's I would say it's good but not great. Even image generation, it's like somewhere like that. Like you might be able to generate very generic images like cats and dogs without much problem, but that's not of real great use. But when you're generating like very corner cases of medical scenarios, images like that, it's still difficult problems to solve, which means they are open research problems.
So I think so the other questions. So the other question is like, what level should we use AI tools to analyze data? So we will answer that question later. And how about the size of data sets AI can analyze at this moment? I will pass that question as well. But he's asking about the final question is, how about Google Data Studio? So would we be able to use Google Data Studio to create data sets?
No,
Not
I
Not
don't
really.
have a lot of experience with Google AI Studio. The premise of that is you give it the data and then work with the data there. So it obviously you can analyze the data. You can you do model training there itself. Um, but can it be used to generate data? Knowing what Google models are capable of, obviously, yes, like Gemini can generate images and texts and all sorts of data, so I wouldn't expect anything less. But can it generate the specific, domain specific data like medical images of certain conditions and stuff like that? I don't think so, but um, maybe these things will these capabilities also come without a long time.
So Chanaka has asked some question about ethical considerations. Since I also have another follow-up question about that, I will ask Chanaka to give me some time to pose that question to the experts. Before that, Isuru and Professor Ragel, let me ask this extended question. So actually, okay, the case is like this. So, for if we consider undergraduate research, they have limited amount of time to actually acquire a lot of authentic data points. So they will not have data points. They might not have data points to publish a study actually, just because they didn't have enough time or research grants to acquire those data. That's one point. The other point is, imagine even if they had time. Not even this. The second point is not even just for undergraduate research. So when we do simulations and stuff, the computational power is expensive, and we might not be able to simulate every data point starting from the grassroots level going through the simulation algorithms also. Even for a really critical mission like simulating a space flight orbit or trajectory, we might not be able to simulate each and every data point starting from the grassroots levels. So in both of these avenues, I feel like there might be some potential in AI to generate us maybe sort of an interpolation, generate us data within the real authentic data. So I have like 4 or 5 things to ask about this scenario, this case. Like I'm asking about generating data sets within like a framework of a few authentic data. Is it okay to do in research? Question one. And the second question is how to actually do it. And the third one is how to actually validate it. I think your demonstration kind of addressed this point already elaboratively. And then the fourth one, what are the tools we can use reliably? And the fourth one, it's an open question. What are the warnings and precautions if we were to do this? Over to you, Roshan sir and Isuru sir.
Isuru, yeah, you can take it. You are the data expert.
What was the first question, Kapila?
Yeah, so basically, you got the scenario, right? I mean,
Yeah,
is it okay to do it in research?
yeah, it is. It's acceptable, but you have to document it properly to put it short. So it's perfectly acceptable to generate data and even augment real data with generated data, but you have to document it properly, because at the end of the day, your results should be reproducible, right? So you need to be able to go back to the data and show somebody else should be able to try out the same thing using the exact same versions of the data that you have created. So real data, you only have to keep a track of provenance to make sure that the data you got these results are with this particular data. Generated data, it's very easy to lose track of. When you're augmenting or creating data sets with generated data, you need to make sure that it's documented properly in your research publications so that somebody else can go and reproduce this.
So, do we have like one of your accepted frameworks how to document synthetic data versus authentic data when you present or when you submit to a repository?
I don't think I have anything to show right now.
I personally have not seen something like that.
Yeah, maybe this is something that maybe we can get back to at a later point. I don't have a quick answer to.
Yeah. So I think what I see is like people annotate data and mention it in the papers and stuff in their own ways. I mean, like foreseeably distinguishable manner. In one way
Yeah,
or another, they would do that.
yeah.
Maybe there are tools, maybe there are frameworks, maybe it's again something you guys could do.
The general way is like when we are using generated data for model training, you end up doing comparisons with where this is where these public data sets become useful. You end up using benchmark results from public data sets, publicly available data sets for the same purpose, a near close purpose that you can get from that compared to the generated data. So nearly always when you're publishing a data set as a data set paper, you would do some benchmarking like that using available either when you're benchmarking a data set, you need benchmark models. When you're benchmarking models, you need benchmark data sets. So
So this is like we are
using
benchmarking our synthetic data using our authentic data
yeah, or yeah, our
in a way,
or
in a way.
either yeah, available, yeah. So that is the nature of things, that the way we do this, whether they are like standardized frameworks, I'm not equipped to answer that right now.
So the second question is actually how to do this synthetic data generation. I think the entire session was about that and everything. So can you actually give us a few tools or again, places that we as spectators, audience can, search and learn?
Yeah. Yeah. Now, one of the easiest good ones is you can go to huggingface.co. Hugging Face. Maybe let me show you. Let me see if I can quickly show you. This this is a place where you can find data sets as well as models. So you can try out models which others have published here to generate data. So it takes a bit of exploring to figure out. So you can go to models and see what generative models are available, others have published. Use them to generate data. For example, things like one thing that we tried out was ECG generation to diagnose particular conditions. There were models that were already there. Even I think we are also trying to publish the models that we've been making on ECG generation as well. So such things are there. So you can go and try out and compare and see how how the actual generated ECGs are representing particular cases, things like that. So this is a good place to play around.
So do we have these some pre-baked tools or like websites that we can say upload 6 data points and download 20 data points by answering a few questions about the context or anything. Do we have such things? If you have them, is it advisable
Yeah,
to?
so tools like Label Box, tools like
Yeah.
this have such capabilities, but like I said, not all those capabilities are available for free. There are certain things that you can do for free in tools like this. So this is like a very popularly used tool, Label Box, for dataset generation and annotation and stuff like that. You know, so foreign, big universities usually have access to these tools, the paid versions of these tools, but unfortunately we don't. So yeah, that is why we are trying to build tools
Oh,
to help with that. But yeah, there are stuff that are available. You can do certain things for free, but not all, obviously.
so I think you already kind of answered this question, but in the sequence, the third question is like, if we do it using those tools or some other way, how to actually validate it in a way that the research committee would accept it? There's no one straight answer for this, I know.
Yeah, one thing is that the benchmarking,
Yeah.
that's the way to show whether your what you created here is valid or not. There are other ways like expert validations, like manually doing expert validations. Say even when you're collecting and curating data, we usually have to do this. When you're at the time of publishing, we have to say how the data set was validated, right? So if it is medical data, who are the medical experts? What are their backgrounds and qualifications to give this particular expertise into the data labeling? So all these things go into the data set paper at the end of the day to show that the validity of what you're presenting here. That is something that a publisher would ask you. How is your data set validated? Who are these experts who brought in the expert values? So yeah.
And the final question is actually, yeah, it is also, I think the answer was discussed among this 2-hour discussion. So what are the warnings or precautions that we should take seriously if we are going to do this dataset generation business?
So yeah, like we were discussing earlier, the first thing is not to fall into the trap and take the generated data for granted. Because if it is that easy, then there's no problem for you to solve there, right? So yeah, not to take it granted is the first thing that you need to be aware of. Make sure that you, from your methodology of your research, bring in that validation aspect into the data, the expert data. That is what you're contributing at the end of the day. Then avoiding risks of these the biases that the generated data can introduce, like the random noise versus the systematic errors that we've been discussing earlier. And then what would happen when you're iteratively using more and more generated data to for model training. What do you have to think about when you're when in the training process? When do you stop? So these are like things that you have to pay attention to. So yeah, the main thing is to be aware of the trap of taking these AI tools for granted. It's there for you to use productively to improve your productivity, but it can't do the work for you.
Okay, so now it's nice you're saying that it can't do the work for you. Yeah, so basically, I will now take Chanaka's question, and actually, what he asks is, so could you please elaborate on the use of AI generated data specifically? I would like to learn more about the ethical considerations involving in using AI generated data in research. What are the
Right. So
ethical
I think that's
frameworks?
an important thing that we didn't touch upon much. So, I mean, in general, we talked about ethical concerns in using data, right? So, there are concerns where you are tracing, say, are you able to trace trace from the model or the data back to the origins, back to the source, where individual people who have given the consent and the data to be used for this research. That's something that we should be really careful about. You should not be able to trace back to sources. So this can happen easily, like if you take say medical images again, say x-rays for example, radiographs, you would have the patient data included there in the x-ray, like the names and certain other IDs or whatever. So removing this from the images is one of the first things that we usually do. And that's actually one place where AI actually helps, without doing manually to remove all these parts from the images. Now you can use AI to remove do this de-identification quite easily. But some information, like like I said earlier, it's not very easy to remove. There are ways that sometimes, even if you remove all this easily identifiable information, you still can trace back to sources after you built your models and tested and validated and all that. You still can trace back, because of the nature of the data, like the very rare corner cases, it might be possible. So those are some things that you have to be aware of. One other thing, particularly in about generated data, is where the publishers, reviewers are particularly paying attention to is the leakage. So you can generate data and use the generated data, but by the nature of the way that you generated the data, you use some real samples to train or make the model to generate the data. Certain samples can creep in to the generated data, and you have to avoid that happening. There are ways to do that. So that is like a critical step. Avoid leaking the real data into the generated data, because it's just another statistical point at the end of the day, right? Can you generate the exact same data that you were trained with? It's possible. So we had to avoid that. So the models can be adjusted to not do that. Otherwise, that can be a potential issue, especially because you are generating this data for rare situations. Then the generated data can be traced back to the origin. So something that you have to avoid, then that's an ethical concern.
So thank you, Isuru. So, Ragil sir, do you have any takes on the ethical considerations on synthetic data?
No, so I mentioned like something while we are discussing. One of the aspects I mentioned is about the for what we are generating the data for, right? So if it's some human behavior, okay, maybe for just for training a model, it's okay, but for use, obviously, it's not, right? So because we don't think such situations are still properly captured or the tool that generates them. In fact, I see some even guidelines in certain, if I'm right, so data-related journals. They are talking about, okay, so human behavior or human or something else, like even opinion, right? So opinion type surveys data, you don't generate them, right? So there are certain ones where we are limited to do so because we think so it's not ethical to represent real human opinion using generated data. Right, so that's one additional aspect I wanted to add, and I think Isuru has covered most of the other synthetic data related issues.
So I think this will be like the final question for the day. So let me set the backdrop by saying, at the end of the day, for researchers, at the beginning of the day, everything is data. So even if we create an image using AI, I mean, an image is a data set, right? A video, an audio clip, everything is like, if you generate it using AI, we could consider it, synthetic data set. Now, again, we so far talked about harmonizing the authentic and synthetic data because our context was research today. I mean, this series, the context is research, right? So I don't think in research anybody would oppose generating data on top of authentic data and distinguishing it, right? Because at the end of the day, even though we start with data, we will walk away with some abstract inferences. That is what research is all about. Now, the thing is, if we zoom out a lot, if you go to the world arena, it might not be the case. It might not be this kind of thing or generating synthetic stuff might not be accepted because the reason I'm saying is, I mean, a few hours ago, I saw Taylor Swift actually has filed for some sort of copyrights or protection against, sort of imitating herself. So basically what I saw is like through a patent firm or so, she's trying to copyright. Her voice and the image or appearance. So for the voice, she has submitted 2 specimens. I think it's just, hi, I'm Taylor Swift and hi, it's Taylor, like two, two voice clips and also 1 photograph. So she has submitted those things and they are trying to make, I think basically, I think what is going to happen, what she anticipated is like, in this image, if you're stable diffusion and so you can select like, I need this kind of an image, right? I think, I don't remember the name of the studio. There was this big thing where people could create the iconic kind of output of that studio on a free platform, but it would have been copyrighted and that thing was there, the debate was there. I think she is trying to extend it to voice and even a choreography, dancing kind of a thing. So now the thing is, this is the exact opposite we discussed. Once you get a data set or something, how do you once you get a data set without any flags or annotations or any kind of ethical declaration, so what she's asking or what the community, part of the community might expect is how to distinguish the authenticity from the synthetic data. I mean, and would it even be possible? I'm asking this as an open-ended question. She's trying to do it. I don't know whether it's possible.
So the question is to differentiate between the synthetic data and the
Authentic
real,
data.
authentic, right? So
Yeah.
the short answer is no, right? So the whole idea of generating this, if we can generate it as good as possible, the whole research of all
That's what
what
I
is.
felt as well. Yeah,
So it's very similar. It's a plagiarism issue, right? I mean, it's
exactly.
an extended plagiarism problem, and there's no solution to it, and unless we being genuine and open. No, okay. So unless we being is one part of it, but we should bring a culture like this research culture, like what Tisru is talking about now, right? So what he said was, okay, in research we can just declare and say, okay, so this is synthetic, not that I went to a hospital and collected this, right? So can we bring a culture such that it's acceptable and then it's okay, but otherwise I don't. It's going to be very difficult to differentiate.
And if we can differentiate, what's the point even, right?
If we can't, I mean, there should like where we are going towards is a place where we can't differentiate.
It's like the pseudo-random numbers kind of a thing, the
Yeah.
textbook
Yeah,
example.
yeah, the difference is becoming small and small, and in certain cases, it's indistinguishable.
Yeah, I was just jokingly saying the other day. So now I mean, it's both ways, right? So one is okay, the synthetic or generated content is coming more closer to the genuine one, but at the same time, because the genuine ones are also getting, what do you say? Uh, Disturbed or diluted or I don't know the right word. I couldn't find the right word right now. But the whole idea is if you listen to people talking, or if you listen to people presenting, or if you listen to people orating, there's a lot of AI in it now. So it's the other way around also is happening, right? So the genuine one is also getting polluted.
Challenged. Oh,
Polluted.
yeah.
Polluted. That's what I was looking for. So polluted. So it's both converging, and it's going to be faster than just the generated one getting as good as a genuine one.
Yeah, absolutely agree with what Professor Raghul was saying. So it's becoming more and more difficult to differentiate these stuff. Certain things it's not possible now, like most text-based plagiarism. It's impossible to detect. I mean, people still come up with tools to, tools that claim that they can distinguish, but these are like snake oil stuff. Um, you can't really do it anymore. With images, there was a sort of like a window where you can distinguish between generated images versus real ones. That's also, closing or almost closed. Video somewhat, following the same path. But the thing is, like we were discussing earlier, in domains like, say, medical research, generated data are perfectly accepted. Say, for example, in some of our research about using ECGs, one of the biggest data sets that's available is there's something called PTB Excel. It's a European data set. It's generated. Yeah, it's a deep fake generated data sets and data set, and that is like one of the biggest benchmark data set that's available. The reason is because of all the ethical concerns about using real data, real patient data. There are a lot of ethical concerns. So because of that, based on whatever the little real data that you have, researchers have created these big data sets which are more useful now, but still you have to be mindful to not let the data, original data, source data leak into the data set. So things like that you have to be mindful very much, but it's perfectly accepted and becoming more and more common thing to make and use synthetic data. So, and like Professor Raghul was saying, it becomes part of the culture, the way we work, and the policies and the regulations also, they are built around that gradually to support such users. So when it comes to personal intellectual property and when you have the commercial value attached to these things, these things become bigger, real issues. So like artistic content, these things are issues, and but I think eventually you will come up with a mix of a policy based and what do you call honor code based
Oh,
solution
yeah,
at the end of the day.
Okay, so I think it's all about on having like self-declaration or something. But I recall this story from my childhood. There was this guy called Nasruddin. He was walking towards the village market, and in village markets we have these people who do these shows and collect money, right? There's this guy. He would cry like a pig, oink like a pig, and people would throw money at him. So he could do it like so realistically. Let's say it's an AI model, so that he could like oink like a pig and people would buy it as like very realistic. Not real, realistic. People would know it is not real, but he would be appreciated for being so realistic. And then after a while, Masudin also comes to the other side of the road, and he would stand still and he would also oink like a pig. And then people would say, you are actually faking. You're not doing a good job. The other person on the other side of the road could oink like a pig very realistically. And then what Nasruddin does is he would open his jacket, and inside his jacket there's a real piglet. And actually, the authentic person was Nasruddin, but people were recognizing the other guy. Let's say the AI. Now, my question is actually. As you ended your previous answer, we might have, or already have, a real need to benchmark or trace back to authentic data. So if we consider this as a research question, how would we go about it? Like developing an AI tool or framework or something that could really trace back.
Trace
Mm,
back to the origin, right? So that
Origin.
is again going against the ethical considerations. It might
In
have
this
other.
yes, sir. In medical image processing and all, yes, it might be, but it might be required by law if we consider artistic content creation and copyright infringement kind of
Yeah,
issues.
that it might be possible to have some signatures, but then can't we generate those signatures is the next question. Yeah, we'll leave it open, I think.
yeah, there's no definitive answer, I think, but
Maybe it's a dead
yeah,
end. We cannot do it.
I don't know. I've seen the bits and pieces of this,
Yeah.
like for this intellectual property violation, some people, powerful entities are suing other powerful entities. But how to actually validate it? Can you go back and look at the weights of a model, like a massive model? You can't even comprehend the weights. It's not humanly possible to do that, but maybe it's possible for machines to do to a certain extent. Um, it's becoming more and more difficult because how knowledge is represented in within these models, it's not easily, what do you call, it's not very transparent. It's You can't go and diagnose it easily, the way the models are internalizing knowledge. So it's very difficult to go and say that this model has internalized this particular intellectual property. People are trying to do that, because there's a lot of financial value in doing that. People are trying, but as far as I know, there's no definitive answer to that. Maybe it'll come to be, but yeah, at least for now,
It's an interesting problem.
yeah.
Yeah. So, in the interest of time, I think we can wind up and maybe we can talk about explainable AI and other things in a different forum. I think in this 10 session series, we did not include it because it's not directly relevant to how to use research, how to use AI for like general research. Maybe through core AI also we could address that need as well. So in the interest of time, I would really like to thank Professor Roshan Ragil, who's our host in residence for this talk series. And also we would warmly appreciate the contributions from Dr. Isuru Navin and his students to this particular session on generating data sets using AI. And I think, we had some questions answered as well. Thank you very much, both of the resource panelists and the participants. So before we wind up and, sir, your final thoughts for today? Or we
Yeah,
talked too much today?
yeah. We have been talking a lot about data, and I think this is in addition to it being part of a research process. I think data is important even within or outside this context, outside the research specific context, because nowadays with all these large language models that are coming in the picture, this is something that is important. And there were people, I think I saw asking questions like whether it can be done, whether there's enough time. I think we don't have to wait until you start a research to start collecting, curating data. You can start early, get involved, and we have a lot of manpower and know-how within the university systems, including Perajaniya, from wherever you are. So we should be able to support and do data collection and curation enough so that we can actually, my concern is to solve our problems, including problems like what ISRO is solving, medical locally relevant medical problems, but at the same time representing Sri Lankan data to reduce the bias of large language model type situations. It's all related to data. So I think we should take it seriously and not see it as a problem that we had to solve. Data as a problem. Yeah, thank you, Isuru, for taking the time and sharing all the ideas.
Thank you, Professor Akhil. Isru, any final thoughts before we wind up?
Um, Not really. Say thank you very much for having me for the talk series. It's been a pleasure. The last thing I would leave you with is the very first thing that we talked about. Make sure your data aligns with the research question. That is the most fundamental thing, generated or not. Make sure the data aligns with what you are trying to solve here as a research problem. Otherwise, it all goes out of the track very quickly. So I'll leave everyone with that.
Thank you very much, Isru, for all your efforts today. And before we wind up, actually, we will be having our next session most probably on 20th Wednesday, May 20th, and that will be on converting ideas to research questions. That will be our fifth topic of the talk series, actually. So looking forward to see you all in that talk as well. So in the interest of time, we talked a lot today. Let me wind up the session for now, and we are thanking our resource persons again and the participants again. Good night, everybody.
Thank you and good night. Good night, David.
Good night, sir. Good night, Isra.